In this video, we are looking at construction and loci. So there are some questions which you want to answer. The first one, construct triangle ABC in which AB equals 8 centimeters, AC equals 6.5 centimeters, and angle BAC equals 60 degrees. The following question, construct the locus of points equidistant from AB and BC, followed by construct the perpendicular bisector of BC. Then B part 1, shade the region inside the triangle containing the set of points which are nearer to BC than AB and also nearer to C than B. Then you want to measure and write down the length of BC. Finally, we want to describe the locus represented by the perpendicular bisector of BC in question A, part 3. Okay. So we are going to answer our questions one at a time, step by step, so that it can be easy for you to follow along. So at first, we want to construct triangle ABC in which AB equals 8 centimeters, AC equals 6.5 centimeters, and the angle BAC equals 60 degrees. So I'll start by constructing the baseline AB, which is equal to 8 centimeters. So I'm going to measure 8 centimeters using the ruler and compass. So my radius of 8 centimeters, okay, there it is. You can see that's 8 centimeters. Right, so with A as my center, now with A as my center, I'm going to draw an arc which cuts this line so that I can locate the position of point B. Okay, so B is here, so this is my B, so this is my AB, which is 8 centimeters. Now we are told that angle BAC is 60 degrees, so it means the angle of 60 degrees is at A here. So I'm going to construct an angle of 60 degrees at A. So with A as my center and the suitable radius, I'll construct this arc. First of all, remember I want to construct an angle of 60 degrees at A. Now, without changing the radius, I'm going to choose this point where the arc intersects the line AB as my center. Okay, and then construct another arc which cuts this one here. Okay. Now I'm going to draw a line from A right through this point of intersection of the two arcs. Okay, like this. Okay, so that's here we've got an angle of 60 degrees. So the next thing is now to locate the position of C. So we are told that BAC is 60 degrees. So it means C is along this line. And we are told here that AC is 6.5 centimeters. So I'm going to measure 6.5 centimeters using the compass and the ruler. Okay, so now you can see that's 6.5 centimeters. Now with A as my center, I'm going to draw an arc which cuts this line here so that I can locate the position of the point C. Okay, so C is here. Okay, so let me just write C here. Okay, so finally, for us to construct our triangle, remember we are constructing triangle ABC. Okay, so this is an angle of 60 degrees and AC 6.5 centimeters according to this information. AB 8 centimeters. Okay, according to this information. So now for us to complete our triangle, you have to join point B to C like this using a ruler. So B is here and C is here. So in the exam, they don't tell you that join these 2 points so that you can come up with a triangle. So you have to know that for you to have a triangle, a complete triangle, you have to join these 2 points B and C. Now, after constructing our triangle ABC, we want to construct the locus of points equidistant from AB and BC. So equidistant simply means equal distance, okay? So locus of points equidistant from AB and BC. If you look close, you can see that the letter B is being repeated here, AB, BC. So for us to construct the locus of points equidistant from AB and BC, we choose B as our center because it is the letter which is being repeated here, AB, BC. So we choose B as our center, and then we open a suitable radius. Okay, so this is AB, this is BC. So I'm going to draw an arc which cuts the line BC like this, and another one which cuts the line A. Okay, my canvas is shifted, so let me go back to B again. Okay, another line which cuts AB. Yeah, okay, and then use these 2 points here where the axis meets A, B, and BC as my centers. Okay, like this, and then I'll construct the suitable radius and arc somewhere here. Okay, this one, and then use this other point also as my center. I'll construct another arc to meet the previous one. Okay, so my canvas is shifted. Let me go back again. Okay, this one. Okay, so now I'll take my ruler and join the point B with the point of intersection of these 2 arcs, something like this. Right. Okay, so I've now constructed the locus of points equidistant from AB and BC. As you can see, if you want to describe this locus, it's just the bisector of angle ABC. But this angle, this one, is equal to this one. So this is just a bisector of angle ABC. Now on question A, part 3, I want to construct the perpendicular bisector of BC. So this is our BC. So I want to show you how to construct the perpendicular bisector of BC. Okay, so we open a suitable radius and then choose, let's say B as our center like this. So the suitable radius must be longer than the middle point of BC. As you can see, that my radius is greater than the middle point of BC. Okay, so with the B as my center, I will construct an arc here without changing the radius and the center. Another arc here. Okay, this one, and then I'll choose now C as my center. Remember, I want to construct a perpendicular bisector of BC. A perpendicular bisector is just a line which passes through the middle section of our line BC in this case, and this same perpendicular bisector will form an angle of 90 degrees, okay, with the line BC where they meet. So another arc here. Okay, now the next thing is to join the points of intersection of of these arcs. So the first point is here and other one is here. So this line is the perpendicular bisector of BC. So it's going to pass through the middle section of BC, and at the same time forming an angle of 90 degrees. Okay, so here it's 90 degrees. Okay, so it's called a perpendicular bisector because if you measure from here to B, it is the same as from here to C. So it's a bisector. It bisects BC, or it passes through the middle section of BC at the same time forming an angle of 90 degrees. Okay, so let's move on. Now we want to shade the region inside the triangle. This is our triangle containing the set of points which are nearer to BC than AB and also nearer to C than B. So we want to shade the region which contains the set of points which are nearer to BC. So this is BC, nearer to BC than to AB. Okay, and also nearer to C than to B. Okay, so the region which contains a set of points which are nearer to BC than to AB and also nearer to C than to B is this one here. So I'm going to show you the region by shading. Okay, this whole region. Okay, this one, which is bound by this and this line and also this line and this line. So that's the region which satisfies the given condition. Okay, so let's move on and finish our work. Now we want to measure and write down the length of BC. Okay, so the length of BC, so using our ruler, as you can see, yeah, the length of BC is 7.5 centimeters. Okay, so let me write here BC equals 7.5 centimeters in length. Okay, so finally we want to describe the locus represented by the perpendicular bisector of BC. Okay, this is BC and our perpendicular bisector is this one. Okay, this line. So I want to describe the locus represented by this line. Okay, so the locus of points represented by this line it is the locus of points equidistant from B and C. Okay, it is the locus of points equidistant from B and C. That's the description of this perpendicular bisector. Okay, so thank you for watching. Meet you in the next videos.